Welcome to part 44 of our series on building a Zelda-like game in Phaser 3. In this video, we'll add the boss's main attack mechanic using a custom Dagger class. We'll create directional Dagger attacks, handle spawning and hiding the weapon, and connect everything on the prepare attack state. We'll also cover the boss defeated event, implementing a spawn delay, and wrap up the core of the boss battle logic. If you're new here, this is part of a full series where we create a Zelda-inspired game from scratch. Check out the playlist link in the description to start from the beginning. Alright, let's dive in and give our boss some deadly attacks. Now that we have our logic in place for our boss states, it's time for us to give our boss our weapon so we can attack our player. So for our boss, we'll be creating a new weapon type, a dagger, which our boss will throw at our player after he finishes teleporting. To get started with our changes, first we need to create our animations for when we throw our dagger. So let's jump over to our preload scene. For our dagger, we'll be using a sprite sheet, so let's copy this logic here. We'll paste it. Now for our asset keys, let's do our dagger. We'll update our reference here. And now for our frame rate, we're going to do 16. And we want this to repeat, so let's do -1. Now that we have our animation, let's create our new dagger class. So if we go into our weapons folder, let's make a new weapon. Let's make a new file. We're going to call this dagger. Let's go into our sword class. I'm going to copy our logic from here. Let's paste it into our dagger class. We'll update our class name. So we'll do dagger. We'll have it extend our base weapon. Now for our dagger class, we'll need to set this up a little bit different than what we did for our sword class. For our player sword, our animation is baked into our player sprite sheet, so when our player attacks, we're actually updating our player game object. For our dagger game object, we're going to be creating a new game object to represent our dagger that we're going to throw across our screen. What we'll need to do is we'll need to have our boss play the attack animation when he attacks, and we'll need to play our animation for animating our dagger across our screen. So to do this, we'll want to add a new game object to represent that sprite. So on our class, let's add a new property. We're going to do weapon sprite. This is going to be a phaser, our game objects, and then our sprite. And while we're here, let's add in one more property. We're going to add in our weapon speed. And so this will be the speed that we're going to throw our dagger across our screen. For this will be a number. So now to create our weapon sprite, we'll need to add in our constructor. So let's open up our base weapon class real quick. I'm going to copy our logic here for our constructor. We'll come back to our dagger. Let's paste that in. Now let's add in our imports. So we'll have our weapon component. We'll have our weapon attack animation configuration. We'll have our base damage. And then we'll also want to add an argument for our weapon speed. Now we can call our super method and let's pass in those properties. So we'll pass in our sprite, our weapon component, our animation config, and then our damage. And now we can create our weapon sprite game object. So let's move this code here. Let's do our weapon sprite. We're going to set that equal to our sprite, our scene. Let's do add. We'll do a sprite. Now for our position, we'll do 0, 0. Let's do our asset keys, and we want to do our dagger. Do set visible. Let's set it to be false by default. Let's add in our origin, so we're going to do 0, 1. And now we want to play our animation, and so we're going to do our asset keys, and then our dagger. After we create our game object, now let's update our weapon speed. So we're going to do our weapon speed. We're going to set equal to our weapon speed we provide as an argument. So now for our dagger, since we're going to have a separate game object we're throwing across our screen, we'll want to update our physics body that's tied to our weapon component to match the size of our sprite that we're adding to our game. To do that, I'm going to copy this line of code here from our attack up. And so now we'll call set size, and now we're just going to reference our weapon sprite. We're going to grab our width, and now we want to grab our height. So before we update our attack methods, let's update our boss class to have an instance of our new weapon. So if we go to our draw class, let's go to where we create our weapon component. Now we'll want to assign our weapon. So we're going to do this, our weapon component. Let's do our weapon. We're going to set it equal to a new instance of our dagger. So now for our configuration, we'll pass in our game object. Let's do our weapon component. Now we'll need our animation configuration. So for this, we'll have our down key. This will be our draw animation keys, and then we'll do attack down. Let's copy that line of code and do our other directions. So we'll have our up, and then our left and right. Now we'll have our attack up, and then we'll have our attack side. After our animation configuration, now we want to pass in our boss's attack damage and our attack speed. For these, we'll add new properties to our configuration. So let's do our enemy, boss. Let's do our attack damage. And then we'll do our enemy boss, and we'll do our attack speed. So let's copy one of those. Let's open up our config file. We'll go to our boss enemy. Let's do export const. We'll paste that in. So now for our attack damage, let's do 1. And jump back over here. Let's copy our attack speed. For that, we'll do 160. Let's save. We'll come back to our boss class. Let's update our imports. So after we save and our browser refreshes, we should see after our boss teleports, we now play our attack animation since our boss actually has our weapon. So to make it a little bit easier to test attacking in our various directions, we're going to update our boss's teleport logic to go to one location. So let's go into our teleport state. Let's add a new variable, new const. We're going to do our random location. And we're just going to set equal to this, our possible locations. And now we're just going to reference our first element in our array. And then we're going to temporarily comment out this line of code. So what this will do is after our boss teleports, he should always teleport to the top of our room. So now that we have our boss attacking, we can start updating our logic here in our weapon class. So let's start in our attack down method. So when we attack with our weapon, we no longer need to update the size on our physics body. Instead, we'll want this to match our weapon sprite width and height at all times. So after we attack with our dagger, we'll want to make our game object visible and then update its position to match where our weapon component is on our boss. So let's remove these lines of code here. Let's reference our weapon sprite. First, let's do set position. Now let's do this. We're going to do our weapon component. Let's grab our body. Let's grab our position. We'll grab our X value. Now we'll do the same thing for our Y value. That's called set visible. We're going to make it to be true. So let's save. So after our boss attacks, our game object will now be visible on our screen. So now we'll need to update the properties in our game object to actually have it face and be thrown at our player. Alright, so to do that, first we'll want to update the origin of our game object. So let's do set origin. We're going to do 1, 1. Now we want to update our angle. So we'll do set angle. We'll do 180 to rotate our game object fully around. Now let's do set flip Y. And we're going to set this to be false. So now after our boss attacks, our game object will be visible, and we'll see our dagger is now aimed at our player. Now, we just want to update our game object's velocity, so then that way it flies towards our player. So let's do this. We reference our weapon component. We want to grab our body, and now we want to update our Y velocity. We're going to do set velocity Y, and now we want to match our weapon speed. Alright, so now we save. After our boss attacks our player, we'll see now our physics body for our dagger moves across our screen, and once it collides with our player, we take damage. Now we just need to fix our bug where our game object sprite isn't matching our physics body. To do that, we'll need to add in our update method so we can update our position. So let's do public, we'll do update. For our method, we won't return anything. Now we just want to update our weapon sprite, and we want to update our position. So we'll do our weapon sprite, set position, and now we want to grab our physics body's X and Y value. So let's do this, our weapon component, our body, we'll grab our position, let's do X. I'm going to copy that, and then we'll do our Y value. So now we save, our boss should attack, and now our game object should be thrown at our player, and our sprite matches our physics body. And so now, after our boss goes to attack a second time, our game object is going to continue moving from where it was at previously. To fix that, we'll need to reset our physics body position on our weapon component. So let's come back up to our attack down method. I'm going to copy this line of code here where we update our positioning. Let's paste that. So now when we attack down, we want to reference our sprite, our X value. We're going to subtract 7. And now for our Y value, we want to add 20 so it's in front of our boss. Now if we save, boss should spawn our weapon. It should get thrown at our player. And now our boss should teleport again. And now our dagger will respawn back in front of our boss. Nice. Now that we have our logic working for respawning our boss's game object, when he attacks a second time, now we just need a handle. Once our animation is finished, we want to hide our game object. For that, we'll want to use our attack animation complete handler, and once this is invoked, we'll want to hide our game object. To do that, let's copy this block of code here. We're going to come to our Dagger class, and we're going to want to override it. So let's add in our method. First, let's do super. We're going to do our attack animation complete handler, so we can call our parent class. That's going to allow us to remove these 2 lines of code. And now we want to hide our game object, so we're going to reference our weapon sprite. Let's do set visible. We'll set it to be false. And now we'll want to reset our velocity on our physics body on our weapon component. So let's do this. We'll do our weapon component. We'll reference our body. And now we're going to do set velocity X. Let's do 0. Let's copy that line of code. And now we'll do the same thing for our Y value. Let's save. So now when our boss attacks, we should throw our dagger. Once our animation's finished, it now disappears from our screen. One other enhancement we'll want to do is after our dagger hits our player or collides with one of our walls, we'll want to hide our game object at that time. To do that, we can use our onCollision callback method that we have in our base weapon class. So let's copy our block of code here. Let's come into our Dagger class. We'll paste that in. So now in our parent class, since we don't do anything, we don't need to call super. So now in our method, all we want to do is hide our game object and reset our velocity. So what we'll do is let's copy this. We're just going to call that method. All right, so now if we save, if we have our boss or our dagger at our player, it should now disappear after it collides. Nice. All right, so now we just need to add in the rest of our logic for having our boss attack in our other directions. So let's start with our attack up method. Let's copy our logic from our attack down. We're going to paste that into attack up. So now for our physics body's position, we'll want to update our x value, so we're going to subtract 8. For our y value, we'll want to decrement this, and we're going to do 25. Now for our weapon, since we're throwing this in the upwards direction, we're going to want to multiply our weapon speed by -1, so we move it in the correct direction. So now for our weapon sprite, we'll update our origin. Let's do 0, 0. We'll update our angle. We want to do 0. Flip Y will set to false. And now we want to do our direction, and we'll do our direction up. We'll copy that. Let's go to attack right. We'll paste it. So now when we attack in the right direction, for our x value, we want to increment this by 10. For our y value, we want to subtract 5. Because we're attacking to the right, we don't need to multiply by -1. For our speed, now for our origin, we'll do 0 for our x, we'll do 1 for our y. For our angle, let's do 90. And now we want to do our direction right. Finally, for attacking to the left, paste this in. Now for our direction, we want to subtract 25 from our x. For our y, we'll subtract 5. Now for our velocity, since we're throwing it to the left, we'll want to multiply this by -1. And we need to make sure this is set to our x. We'll come back up to attack right. Let's do set velocity x. So now down here, let's update our origin. We're going to do 0, 1. We'll do 90 for our angle. And now we want to set flip y. We're going to set this to be true. So what we're doing here is we're just mirroring the same values that we're setting for attack right, but then we're flipping our game object on our y axis, and then that way it'll be in the other direction. Finally, for our attack direction, let's do left. All right, so now if we want to test our changes, let's jump over to our teleport state. We're going to update our random location. We're going to use our first index, so our boss should be over on the left. All right, so now if we save, our boss should teleport over to the left. So if we move to the right-hand side, our boss should do our right attack. Now if we move towards the top of our dungeon, our boss should appear below us and attack in the upwards direction. Now, let's update our location. Let's do our next index. Now our boss should appear on our right, and he'll attack to the left. Nice. So now we've tested, let's get rid of this logic here. We'll re-enable our random location, and now we should be able to have our boss teleport our room and choose a random spot to attack us. Alright, so after our boss finishes teleporting, he attacks us immediately, and so we're going to add in a small delay to give our player a chance to try to dodge the weapon. To add in that delay, let's go into our prepare attack state. So instead of going straight to our attack state, let's add in a delayed call. So I'm going to do this. Let's do our game object. Let's grab our scene. We're going to do a time delayed call. For this, we'll want to add in a new delay value to our configuration. So let's jump over to our config file. I'm going to copy this line of code here for our teleport state finish delay. We'll update our name, so we'll do enemy boss prepare attack state finish delay. For that, we'll do 500 milliseconds. Let's copy our variable name. We'll come back to our prepare attack state. We'll paste that in. So now in our callback, now we'll want to transition to our attack state. All right, so when our browser refreshes, we'll see now we have a brief window to dodge our boss after he finishes teleporting. However, since we have that delay now, our boss is facing the wrong direction before he goes to attack us. To fix that, we'll go ahead and play our idle animation. So I'm going to jump over to our teleport state. Let's copy our line of code where we play our animation. We'll come back to our prepare attack state. We'll paste that. Now let's save. So after our boss teleports, he should face the right direction and then attempt to attack our player. Finally, for our boss enemy, now we just need to add in logic to handle once we defeat our boss. So for our boss enemies, these are unique enemies in our dungeon where we only want to spawn them one time. Once our player defeats our boss, we want to keep track of that in our data manager. That way if our player ever comes back into our dungeon, we don't respawn that enemy. To add in this logic, we'll need to emit an event once we defeat our boss enemy, so then that way we can update our data manager. So now to add our logic, let's go into our event bus. Let's make a new event. So after our dialog closed, let's do our boss defeated. Copy that. We'll make that our value. So now that we have our new event, we need to emit this once our boss is defeated. So let's go into our draw class. So in our death state, in our callback, once we make our boss no longer visible, now we'll want to emit our event. So let's do our event bus. We'll do emit. Let's do our custom events. We want to do our boss defeated. Now that we're emitting out our new event, we want to update our game scene to listen for this. So let's jump over there. Let's go into our register custom events method. Copy our line of code for our dialog closed. We'll paste that. Let's do boss defeated. And now we'll do handle boss defeated. Let's copy that line of code, paste it here, change this to be off. Let's copy that method name. We'll come down to the bottom of our class. Let's add that in. For our method, we won't return anything. And now we want to update our data manager. So if we open up our data manager class, we need to update our boss defeated property inside our area details. To do that, we'll add a new method to our data manager. So let's come down to the bottom of our class. Let's add a new public method, and we're going to call this defeated current area boss. This method, we won't return anything. Now we'll do this, our data. Let's do our area details. We're going to grab our current area name, and now we're going to set boss defeated. We'll set it to be true. So now back in our game scene, we can call that new method. We're going to do our data manager. We're going to grab our instance, and we'll say we defeated our current area boss. Now that we've updated our data manager to keep track of when our boss is defeated, when we go to create our enemies, we'll want to check to see if we've already defeated our boss. So let's go to our create enemies method. So now when we do our type check here for if our type is 3, now we're going to check to see if we've defeated our boss. So we'll do and not, our data manager, our instance, we'll do our data, our area details, we're going to reference our current area name. If our boss is not defeated, then we want to create our draw enemy. Alright, so now if we want to test our logic, let's go into our config. We're going to update our boss's health. We're going to drop it down to be 1. So now after our boss spawns, we'll have our boss attack our player. Let's attack our boss, and now we'll see right away our door opens up, and now we play our animation for having our boss be defeated. Nice. So now for our boss defeated logic, there's a few other changes we'll need to make in our code. So let's have our player leave our room after we defeat our boss. Let's defeat our enemies in our next room real quick. So now if we have our player go back up to our boss room, what should happen is after our player enters our room, we'll see our boss still plays our attack animation, and we throw our dagger at our player. So to fix this in our boss class, we'll need to add some custom logic to our enable object method. We'll want to check to see if our boss is already defeated, and if so, then we don't want to do our logic where we update our state. So let's go into our boss class. Let's come down to our enable object method. We need to update our method here to also check to see if our boss is defeated. So currently in our parent class, this is where we have that check. So let's grab that line of code. We'll paste it down here. And now we should only go into our state if our boss is not defeated. And so one other change we'll do is we're just going to wrap this in a safeguard to make sure we only run this one time. To do that, we're just going to do if. We're going to reference our state machine. We're going to do our current state name. If it's undefined, that means we've not set our state yet. And we'll want to do that now. Besides this, we're also going to add in a small delay, so that way when our player enters our room, our boss doesn't immediately spawn. Instead, we want to wait a second before he appears. So to end that logic, first we're going to make our game object not visible, or set that to be false. And now we're going to do our delayed call, so we're going to do this, our scene. Let's do our time, let's do our delayed call. And for this, let's do 1 second. We'll do our callback, and now in our callback, now we're going to transition to our state. Let's copy our visible code. We want to make our game object visible. So now if we save, once our player spawns in our room, we should now wait a second before our boss appears and starts getting ready to attack our player. One small change we'll do is let's move this to our config. So let's open up our config. Let's copy our line of code here for our delay. And we're just going to do our enemy boss, and we'll say start initial delay. We'll set that to 1000 milliseconds. Let's copy that. Come back to our boss class. We'll paste that in, and now let's save. Alright, so one other change we'll need to handle when our boss is defeated is if our boss was attacking our player and our weapon's still on our screen, once our boss is defeated, our game object will remain visible. And so to fix this, we just need to enhance our logic tied to our disable object method. So let's open up our character game object base class. So now in our disable object method, we'll want to add in a check to see if we have a weapon component for this character, and if we do, if that weapon is visible and we're attacking, we'll want to disable that object right away. First, let's grab our weapons to our weapon component. So we're going to do const weapon component will be equal to our weapon component. Let's do get component. This will be our weapon component instance. And now we're going to pass in this for our game object. Now we'll check to see if our weapon component does not equal undefined, and our weapon component has a current weapon. And then finally, if we're attacking with our weapons, we'll do our weapon component. Our weapon, we'll do is attacking. Now we'll want to call our callback. So let's do our weapon component. Let's do our weapon. And we're going to do our on collision callback. All right, so now if we save, we should be able to test our changes. We need to wait for the boss to go to attack our player. Now if we defeat our boss while our weapon's visible on our screen, we'll hide it right away. Nice. Finally, for our boss defeated logic, one last change we'll make will be tied to when we open up our door. Currently, we have it set up so once we defeat our boss, we're emitting our enemy is defeated event, and when we do our check for if all of our enemies are defeated in our room, our door opens immediately. Instead, we want to change this so our door will open only when we emit our boss defeated event. To do this, we'll need to update our data in tiled. So for our doors, we currently have our trapdoor trigger, and our available values are none, enemies defeated, and switch. We'll want to extend this with a new value that'll be tied to when our boss is actually defeated, so we can tie that to our boss defeated event we're emitting in our game. To add this support, in tiled, we'll want to go to our custom types editor. Under our trap trigger, our enum, we'll want to add a new value. For our new value, let's do boss defeated. Now if we choose our door in our boss room, let's update our trapdoor trigger type, and we'll want to do boss defeated. Now we've updated our map data, we'll need to export out our JSON file so we can import it into Phaser. So let's do file, we're going to do export as. Now for our export, we'll want to update our name, so this will be our dungeon_1.json. So now that we have our new JSON file, we'll come back to our game, and now we'll need to import that file into our workspace. So now to our public folder, under assets, we'll want to go into our images, we'll go into our levels, our dungeon_1, and we'll want to replace our dungeon_1 JSON file. So after we replace our JSON file, we should be able to do a search for our boss's defeated value, and we should see that's tied to our trapdoor trigger. So now we've added a new value to our trapdoor trigger type, we'll need to update our enum and our tiled data. So under our source folder, if we go under common, tiled, let's go into our common.ts file. For our const for our trap type, we'll add in our new value. I'm going to jump over to our JSON file, I'm going to copy our boss defeated, paste that in, we'll have our value be the same. Now that we have our new trap type, we'll need to update our logic in our game scene, so we'll be able to open up our boss door once our boss is defeated. To do this, we're going to update our logic for when we listen for our event for when our boss is defeated, to have it call our handle all enemies defeated method. In this method, we're going to enhance our logic where we loop through our doors and check our trapdoor trigger type. If our trapdoor trigger type is our boss defeated, we'll then check our data manager, and as long as our boss is defeated, we'll open up our door. So to add in that check, let's come down to the bottom of our class, and our handle boss defeated method. After we update our data manager, let's call our method, so we'll do handle all enemies defeated. Now in our method, when we're looping through our doors, let's copy this block of code, we'll paste it, and now we'll say if our trap type is our boss defeated, and if our data manager, our instance, our data, our area details, now our current area, so we'll do our data manager, our instance, our data, our current area name. If our boss is defeated, then we'll want to open up our door. So now if we want to test our changes, let's come back to our browser, let's attack our enemy, we'll see right away our door no longer opens, but once our enemy vanishes and we emit our boss defeated event, our door will now open up. Nice. Alright, so with that last change, that actually wraps up all of our logic tied to our boss. So now in our dungeon, we now have a challenging boss fight for our player once they reach the end of our dungeon. So now that we're done testing our logic, we need to revert some of our changes in our data manager, so we go back to our initial starting room. So let's update our starting room ID and our starting door ID to be 3. Let's come back into our config file, and we'll want to update our boss's max health, and we're going to revert this back to 6. That's it for this part of the series. If you found this helpful, be sure to hit the like button. It really helps out the channel. And if you're following along, make sure to subscribe and turn on notifications so you don't miss the next video. If you have any questions or want to share your progress, drop a comment below. I'd love to hear from you. Alright, thanks for watching, and I'll see you in the next one.